I'm dialing a 35-year-old cell phone that I painstakingly restored to work on the current 5G network.
Yeah, having dinner?
But will the public notice this relic that I'm using? I know I would, but it seems like most of the folks in this restaurant could care less. This is a 1992 Motorola cell phone, often called a brick phone because of its size and shape. And yes, it does feel kind of like a brick. Not as heavy though. I'll show you the process I used to get it working again, but first let's see if we can get any more interest from the public. Walking through this small grocery store, it looked like most people were more interested in their boring modern phones. So I tried an even bigger store, but still not much attention. Maybe I needed a bigger crowd. Finally, after 10 minutes, someone actually took an interest in this phone. Maybe too much interest. So some quick facts about this phone. It's a version of the classic Dynatac, the first handheld cellular phone. It cost around $900 in 1992, which is over $2,000 in today's money. I bought it for $40 in an online auction. It cost the equivalent of $119 per month to use for 2 hours of local phone calls. The phone is analog only and uses the now dismantled 1G network. Today's phones use 5G. Finally, it weighs in at over 1.5 pounds, 4 times the weight of the iPhone 17. So there's a few ways you can get a cell phone this old working again. As I mentioned before, the 1G network disappeared about 20 years ago. So one option would be to recreate that network on a small scale using modern hacker tools. A simple Raspberry Pi tiny computer with a software-defined radio stick and some open source software can emulate that old network. There's a couple of problems with this approach though. First of all, you'd need to carry this base station around with you, keep it powered up, and somehow connect it to the telephone network. That's not very portable. In addition, it broadcasts on frequencies that are now restricted to other uses, so there's that. I don't need the FCC knocking on my door. So if we don't have the network, the other option is to modify the phone. But what's inside an early 1990s brick phone, and why is it so large? First of all, the battery is massive. It uses older nickel-cadmium technology, which is much heavier than today's batteries. Popping the phone open, we can see that it uses many large integrated circuits and surface mount components, which have been replaced by smaller chips in today's phones. The analog RF cages and circuitry are also huge in this phone and mostly replaced with a tiny chip on today's phones. That's why this thing is so heavy. And this was just a phone, no texting, apps, screen, or data. Amazing how technology has advanced since then. Since the internal parts are mostly proprietary and undocumented, and the original battery is long dead and irreplaceable, I decided to build new insides for this phone using modern parts that can utilize the current 5G cell network, all the while keeping its original aesthetics and features. I don't want to turn this into a smartphone, I just want it to look like it's working the way it was originally designed. I figured that a Raspberry Pi Pico 2 microcontroller would be the heart of this phone retrofit because it's small, powerful, and can run well on a lithium ion battery. The first task was to recreate this circuit board that holds the dial buttons, display, speaker, and microphone. I'll reuse the speaker and mic from here, but I'll have to come up with my own buttons and display since the original 7-segment LEDs are difficult to control. I started by cutting a PCB to the same size as the original. That is as close to this as And then I soldered on 21 micro switches and wired them in a matrix using tiny relay coil wire. That was then breadboarded up and connected to the Pico, along with an LCD that could mimic the LED digits. A little Circuit Python coding later, and I had something that at least could input and display dialed numbers. I soldered it all together and then tested the fit in the front of the case, comparing it favorably to the original board. Eventually, I soldered on the speaker, mic, and Pico on a rear daughter card. Also note the small power supply board, which will eventually be connected to this battery to provide a steady 5 volts for the Pico. I'm just going to interrupt here briefly to ask you to hit that like button and/or subscribe if you're enjoying this content and want to see more like it. At this point, I only had about half the phone's required functionality. I could dial numbers and have them show on the display, even lighting the in-use LED. But I'll need a modern phone that can fit inside the case and be controlled by the Pico microcontroller. That's a pretty tall order. But then, enter the BM10, billed as the world's smallest hand-free Bluetooth dialer dual SIM card unlocked GSM 2-in-1 mini mobile phone. It's teeny tiny, and at around $19, I'm willing to pop it open and see if I can modify it to be controlled by the Pico. In fact, I bought a few of them just in case. At first, I really thought they had sent me a toy shell with nothing in it. Really, this thing weighs nothing, well, less than 1 ounce, even with a battery, but it actually works. People might be more impressed by this thing than the brick phone. When I opened up the BM10, I was amazed at the miniaturization, especially compared to the insides of the 1992 brick phone. Everything, including an MP3 player, digital cellular features, OLED display driver, and Bluetooth, is on this one tiny chip. I traced the keypad on the mini BM10 and was able to map out how it was wired in a matrix. Now, if I could just have the Pico electronically press these buttons in the proper sequence, it could make phone calls. I recalled these components from Adafruit that can act like switches and are controlled by I2C, which the Pico can accommodate. So briefly, the plan is that my keypad, which connects to the Pico's GPIO pins, would control the analog switch via I2C. Those switches would in turn electronically press the necessary buttons in the proper sequence to dial the BM10 phone. I'll need to solder a wire to each tiny switch pad. And just to be complete here, the Pico also drives the LCD via SPI. Could this actually work? It would be too complex to prototype, so I took a chance, went all in, and spent weeks wiring this up and testing the code. I kept stacking circuit board on top of circuit board and wiring them all together. Here you can see the 2 analog switches with all the wires that will go to the mini phone's keypad. The mini phone will get mounted here. Then the painstaking task of soldering 15 tiny wires to the BM10 keypad traces began. Finally, it was all wired together. Remember, this was all untested, and basically there was one shot to make this work. Would it turn on? The Pico powered up, but would the heavily modified BM10 mini phone power up too? Amazingly, it did. Now the final test, dialing numbers into the Pico and seeing if they get sent to the dialer. Note the green LEDs that are programmed to go on when a button is pressed. They'll eventually illuminate the brick phone's keypad, just like the original board did. The numbers have been dialed. Now I'll press the send button and hope for the best. Success again, though the code needed to be adjusted to hit the correct digits. Unbelievably, this worked on the first try. However, there's one more critical step that has to work in order to complete the project. Would my giant pile of circuit boards and battery fit in the brick phone's case? I had done some rudimentary measurements, but mostly I just eyeballed it. I did have to make a few minor adjustments, and I also drilled some access holes in the back of the case that will be covered by the huge original dead battery. But finally, everything fit together and the project was complete. So why go through all this trouble? Well, I really like retro tech, and I always wanted a working brick phone, but I missed that era. This is the next best thing. So it's mainly about having fun and figuring out how to make things work together. The brick phone is an iconic piece of 80s and early 90s tech, and now even a museum piece. There's also the wow factor from strangers. Anyway, that's all for now. Thanks for watching, and I'll see you again soon for another neat tech project. Hi, can I call you back?